Hello, my name is Stephen Cowden, Applications Manager at Microchip Technology. Today we're going to use the MPLAB Configurator to set up the ADC and EUSART. We'll start development from where we left off on the previous overview video of the MPLAB Configurator, where we use the tool to set a port pin high. For this video, we will continue to use the PIC-M2 demo board with the PIC16F1937 installed, but we're also going to use the MCP2200 USB to RS232 board. This will allow us to see the EUSART communication on the PC. For the dev tools, we'll be using the MPLAB X version 1.90, XC8 compiler version 1.21, and the MPLAB REAL ICE in-circuit emulator. Okay, let's get started. Let's start MPLAB X and open the MCC demo project we used for the overview video. Once it's open, go to Tools menu and then select the MPLAB Configurator under Embedded. Notice that when you open the Configurator, it successfully read the previous configuration and restored all our settings from the previous video. Okay, let's select the ADC from the Device Resources area first. Once selected, it appears up in the Project Resources area. The ADC User Interface comes up in the Composer area and is added to the list of peripherals in the table view of the Pin Manager. Note there's also a warning in the output window alerting the user that at least one I/O needs to be configured for the ADC. The PIC-M2 board has a potentiometer on RA0 pin, so let's select that pin for the ADC in the Pin Manager. This can be done simply by clicking on the little blue open lock on the RA0 pin. Notice that when you select the pin for the ADC, the lock will lock and turn green, and the other little blue lock on the GPIO is no longer available. Okay, after we select the ADC, let's move over to the ADC User Interface in the Composer area and set up the ADC. Enable the ADC via the Enable checkbox. Right justify our ADC results, and let's leave the positive and negative references at VDD and VSS. We can also customize the I/O name for the selected ADC channel. Since we have a potentiometer on RA0, let's call the I/O POT. That's capital P-O-T. Notice that when we change the name of the I/O pin in the user interface, it's also reflected in the package view of the Pin Manager. Well, that takes care of the ADC. Let's set up the EUSART now. Let's select the EUSART asynchronous mode from the Device Resources area. Notice the Configurator automatically assigns the pins for the UART. You can see this via the package view and the table view of the Pin Manager. Since the pins are already set up for us, let's enable the UART and enable transmit in the UART user interface in the Composer area. Since we want to see what's being transmitted out of the UART on the PC, let's also select Redirect Standard I/O to USART checkbox. Doing this will set up all the necessary code for using the Standard I/O library, which will allow us to use the printf format string in our code. And that's it for the UART. We're ready to generate the code. Okay, let's click on the Generate Code button and close the Configurator for now. If you go to the Project folder and expand the Header Files and Source File folders, you can see the files the Configurator generated. We generated an additional ADC and UART.c and .h. Let's open main.c and scroll down into the while loop. And we'll just add in one line of code to our project. That one line of code will be a printf statement, and it goes like this. Printf parentheses. Inside the parentheses, type the pot value equals %d/r/n, quotes, comma, next type ADC, and we'll use the MPLAB autofill feature by pressing Control spacebar. Let's select the ADC get conversion function from the list of functions and type in the word capital P-O-T in the parentheses, add a semicolon at the end of the line, and then that's it. Let's make and program the device. Now let's open a terminal program on the PC. You should see the MCP2200 as a USB serial port. After selecting it, you should see the string above with the measured ADC value from the potentiometer. Simply turning the potentiometer on RA0 pin, you should see the measured value of the ADC change from rail to rail. And there you have it. We've set up both the ADC and EUSART using the MPLAB Configurator within a matter of minutes. It's almost like cheating. Well, thank you for your time, and for additional information on Microchip's wide range of development tools, please go to www.microchip.com/MPLAB X.